Starting the recording, guys. All right, so Pythagoras' theorem is only for some specific triangles, and it's used to find some specific information. Before we review it, the theorem itself, I want to go through a few ideas just to remind you of some things that you need to know, right? Okay. First of all, this theorem is only for right-angled triangles. Okay. Triangle means it has how many sides? 3. Right angle means it has one right or 90-degree angle. Do you remember the symbolism for that? There you go. It's got a little square in one of the corners. Guys, does it always have to be in the bottom corner? No, it can be sideways. Doesn't matter where it is, right? Okay. Just one right 90-degree angle. Yeah. Oh, it doesn't have anything to do with which side it's on. Okay, yeah. You're cracking me up. Okay, it's the angle, the right angle, perfect corner. Okay? All right. We generally... All right, hold on, guys. Shh. What does it mean to square something?
Times it by itself.
Times itself, not by 2. So, for example, 8 to the second power equals what?
64.
Right. Don't multiply 8 times 2. Multiply 8 times 8. Okay? Critical skill, and one thing that if you get in a hurry, you're going to mess up. So be careful. I'm trying to point out all the errors that you're going to make, if you're going to make any. None of you are going to make them because you're going to remember them all, right? I know this is true. Okay. What if I want to unsquare something in an equation? What is the... Yeah, to take away the square, you just use the square root. And since they are opposites, they simply eliminate each other, right? So the square root of x squared is just plain old what? X. Make sense? Square root of a number. If you can take the square root of a number, in other words, if it is a perfect square, good deal. Square root of 49 means what? 7. Yeah? But what about the square root of 20? No, nothing multiplies times itself to give us that. So what we're going to do is you're simply going to use your calculator to do an estimate, and we generally round it to 2 decimal places. So square root of 20, you got to... Anybody got a calculator out there to...
I can't square on my phone.
Yeah, let's turn it sideways.
10.
Like somewhere between like 4 and 5.
Okay, well just...
It'll be 4.6.
What is it? 4.47, rounded to 2 decimal places? Okay. All right? Now, but guys, look up here, please. Is it exactly 4.47? Then I am not allowed to put what I wrote. There you go. You remember that from before, yes? If you approximate, then you have to put is approximately or is, right? Shh. Okay? All right. Now,
Wait, why is it
because we rounded.
I did.
Yeah. Okay? So be sure to remember that. You want to be as accurate as possible. Okay. Another thing about right triangles that you need to know is we need to know how to label them. They have to be labeled properly. Okay? Which one is the longest side?
The hypotenuse.
Slanted side, right, which is called the hypotenuse. Oops. Right? And we always call that one what letter? Oh, y'all call it H? Okay. H, or you usually in the Pythagorean formula, you usually use C.
Oh, yeah, ABC.
Okay? Yeah. So easy to H or C. For the formula, we typically use C. Okay? Now, you have 2 other sides. Technically, it doesn't make any difference because they're both sides. Yeah? Okay? Yeah, we'll get this. But we usually call this one A and this one B simply because A is the shorter one, B is the longer one. Who cares, though? It really doesn't make any difference. Okay? So, all right? Okay. Now, the formula is used, the Pythagorean formula is used to find the missing side. Pythagorean formula. Side in a right triangle. Okay? Pythagorean formula. Guys, shh, knock it off. All right. The theorem is the idea. The formula is the thing you plug the numbers into. When you use it, it's now a formula. And as a formula, it has an equal symbol in it, which means that it is an equation. There you go, an equation. So all you're going to be doing is creating an equation and then solving it, right? Now, if you do not set up the equation, we will be happy to count it wrong. So you will write the equation, because it tickles me. I don't know. Parent interviews are over. I don't have to be nice anymore. All right. So, just kidding. It's important that you write down what you have, because if you're going to make a mistake doing this, it's going to be some simple error. And if you take the time and slow yourself down to write it down, then you probably won't make as many simple errors. Okay? And that's what it's all about. So make sure you write them down. Okay? So let's talk about the formula. The formula says that a squared plus b squared equals what? C squared. This is probably the only formula you'll ever remember for the rest of your life. Most adults, you can say, hey, what's the Pythagorean formula? And they go, that's that a squared plus b squared thing. Yeah. Yeah. Okay. I don't know. It's just one of those formulas that just sticks because it makes perfect sense. All right. Ready? And all you need to do is remember that this one is C. Does it matter which one you call anything else? Nope. But it doesn't make the slightest bit of difference because you're adding them together. And does it matter when you're adding? Does the order of something matter?
No.
Absolutely not. Okay? So what we're going to do is we're just going to look at a few where we're finding the missing sides. Now, the book makes a big deal out of it. You're looking for the shortest side. You're looking for the longest side. You're looking for the hypotenuse. Who cares? Just put an X in the place of the one you don't know and put numbers in place of the other ones. All right? So don't get all carried away because they break it separately into the shortest measure of the shortest side, the measure of the longest side. It makes no difference. One side is A, the other is B, and the other is
C. You're gonna get hit. C.
Okay? C. All right. C, as in yes. Knock it off. All right, here we go. So let's look at the book. Oh, darn it. There we go. First thing they do is some measurements. If you don't remember your metric conversions and that kind of thing, you might want to go over that. We're not going to spend time in class talking about it very much or at all. But here is one thing you might want to also think about. Sensible units. Would you measure this water bottle in kiloliters? No.
I thought you meant the length of how far.
I like how much it'll hold, the capacity. Maybe liters, yeah. Would you measure this wall in centimeters?
Meters.
Yeah. Would you measure the distance from here to Mount Vic in meters? Right? Make sure you use sensible units. Okay? All right. Here we go. So here's the theorem. A squared plus b squared equals c squared. Do not pay any attention to the way they work this out. I hate it. Now they're showing you how to do it on your calculator, and you can use your calculator, but if you do, you make sure you use brackets if you're doing it. I'm not going to be looking for the work, but I really think you should show as much. You must show the equation, and it's not going to hurt you to show how you got the answer either. You're going to see. I'll show you what I mean. All right. So calculate the unknown lengths of each triangle. how do we, first of all, we can only use this formula when it's what kind of triangle?
Right.
Right. So be careful with that. So, all right. Okay. So here we go. We have this first one.
We're doing 1 or 2.
Let's do, we usually do the evens, don't we? So we're going to call that A, that B. The only one that I have to get right is the C, right? So it's A squared plus B squared equals C squared.
3 squared.
I know A is 3 squared plus B is what? 4 squared equals C, which I don't have, but I know that I have to what? Square it. Now you can call it an X if you'd like. It's fine. Doesn't make the slightest bit of difference to me. I usually just go with the letter that's there, but you could call it X if you want to. Makes no difference to me. So you could use P if you want. I don't care. All right. So now what I need to do first is what?
3 squared.
The exponents first. Yeah, exactly. 3 squared is plus 4 squared is
16.
equals C squared. What's 9 plus 16?
25.
Equals.
C squared.
Now is as C by itself? Nope. I need to unsquare it by doing what? No, be careful. Take the square root of what? Both sides, right? Square root of 25 is what? Square root of C squared is what? But in reality, remember when you take the square root, you really get a plus and minus. But does it matter here? Can I have a negative 5 length? No. So you are always going to want to reject that one anyway. Guys, listen to me though. That might be a type of question that an NCEA exam would ask you. Why do you reject one of them?
Because you can't have
Negative length. Yeah, you can't have negative length. So C equals what? 5 what? Meters in this case. All right. I'm not going to insist that you use the meter. No, it's not squared because it's just centimeter, just meters. C meters. Okay.
On the thing, it's an X.
Yeah,
Oh.
he said you can use X if you
Use whatever letter you want. Okay? I typically use the A, B, and C because that's what it looks like in the formula. But if you want to use X, you're more than welcome to. Okay? How's it look? Think you can do them? Good. All right. Very simple equations. Does it matter if the X bounces around? It's not in the hypotenuse? No. Just wherever it is. Find the missing sides.
I could probably do that.
I know you can do maths now. When you have to do it what?
You know what?
All right. Shh. All right, here we go. So what A is 5.3. Remember, it's always quantity squared. Plus B squared, because B, we don't know the number. You call it X if you want to. Equals, our C is 88.1, right? Can you see that in the gray? Okay. Then, of course, you're going to need your calculator. Okay, you're always supposed to have them out. So what's 5.3 squared? Someone?
I don't know, sorry. 28.09.
Okay. You were so close. Plus B squared. We can't do anything to that because we don't know what it is. What's 8.1? I'm sorry, quantity squared. 8.1 squared is
65.61.
there you go. Now, is my B by itself?
No, you need to take away 28.09 by the other one.
8.1 squared.
Doesn't seem right.
Try it again.
It does seem right because 8 times 8 is 60.
64 plus some decimals. Yeah, you're good. Yeah, it's all right. Okay, now, so we want to get this term by itself. So we first have to move that number.
Take away.
Yeah, and it doesn't have a sign in front, which means we know it's positive. So the opposite of add 28.9 is what? Subtract it from where?
65.
From both sides, right? Over here, it will subtract away, gives you B squared. Over here, what is 65.61 minus 28.09?
80. It doesn't sound quite right.
Did you do it in your... It's 37.
And my natural
Point
hair.
Point 0.52.
Oh, wait.
65.61 minus 28.09?
Yeah, that's right.
Okay. Now, is my b completely by itself?
No, you need to square both sides.
I've got to unsquare it by taking the what?
Square root. both
Square root of what? Both sides. What's the square root of b squared?
B.
What's the square root of 37.52? Rounded to 2 decimal places?
It's 6 points.
Is what is it?
I was just, because 6 times 6 is 36, so I was like, it's probably 6 points.
What is it, Kinsey? Sorry. 6.13.
Tell you guys. Didn't I tell you guys?
And remember, it's about or approximately that. Do not put equals. Okay?
No, how do you get square root on this code? You literally press the little arrow.
If you're going to have any issues with any of these, it's going to be where you're going to have to find the pieces from words, right? So let's just look at this little picture, guys. We have a ladder leaning against a wall, and it's a certain distance away from on the ground. If you can identify which piece makes which piece of the triangle of this, then you can do any of these application problems very easily. Notice that the wall and the ground are where the 90-degree angle is. Yes? The ladder will always be at an angle. So the ladder will always be your hypotenuse, right? And you can call it x, c, whatever, I don't care. But remember that you can never have a ladder straight up. You will fall off of it.
No, you can't.
And if you have it on the floor, it does you no good. So the ladder always does what? Leans against the building or the wall or whatever, right? Does that make sense?
Yes.
Okay, then I expect to see not one test with the ladder is on the ground, which is what I normally see. Can you imagine?
Let us be attached to the wall.
Well, that'd be silly. This is a portable ladder. Okay, how's that? We got to be able to carry it later. All right, so let's look at a couple of these. Sure, we can do that one too. A 4-meter long ladder is leaning against a wall. If the base of the ladder is 1.4 meters from the wall, calculate how far up the wall the ladder reaches. Right? So they've already given you the drawing, so this one's even easier. So you have the straight sides. So that's where your right angle is. And so the ladder is your hypotenuse. It doesn't matter which one you call which. So we can call A, B, C. You can use H if you want to. Why are they using H, you think? You betcha. So, no. H for height. Okay? A squared plus B squared equals C squared. A, I don't know. So A squared. B is 1.4. Quantity squared. C, what is that, 4.0? So just 4. Quantity squared. All right, does everybody see where I got those numbers? Okay. A squared can't do anything with. What is 1.4 squared? Someone?
1.96. I don't think that's correct, but
Yeah, because 1 times 1 is still going to be 1. You're just going to get 1 inch with some decimals on. Yeah, you're okay. And 4 squared is 16. Good. So I'm trying to solve for A. Is my A by itself yet? No. I've got to move that positive 196. What's the opposite of add 196?
Minus.
From where?
From both.
From both sides.
14.04.
So that gives me A squared equals what? I'm sorry?
14.04.
Thank you very much. When you subtract those away. And then we need to unsquare the A square by taking the square root. And gives you A equals, what is the square root of 14.04?
3.75.
Okay. And again, we rounded, so we need to put approximately, even if the book says equals. Okay? The little wiggly equals.
Just say I put the equal sign, could I then just write the number approximately? Write the number.
You betcha. So if I did that, I would add a straight line here, which makes that the right angle, right? Okay?
And that makes that side 3
And
centimeters.
This side and this new line are the same side, so it's 8 centimeters, yeah?
The other one's 3.
And yeah, this one is the whole of 11 minus the 8, which gives you 3.
Which is what I said.
I know, I'm sorry. I was getting there, but I needed to explain why.
Wait, what is
It's my job, man. So, I got to do it right. All right, you ready?
11 minus 8.
A squared plus B squared equals C squared, right? So we have an A and a B and a C. Yeah? So we're looking for C, so that's we don't know that. A is 8 quantity squared plus B is 3 quantity squared equals C squared. We don't know what that is. 8 squared is what? 64 plus 3 squared is what? 9 equals C squared. 64 plus 9 is 73 equals C squared. Are we done? Take the square root of both sides. Gives us 8.54 squiggly line C.
Sorry, 1 second.
Okay. So if you have a shape that the part you're looking at is slanted, just make a triangle out of what you have, and you can find the other values by subtracting from what you know. Yeah. Okay.
Wait, why do you put the number before the C?
That's just big. It doesn't.
It just because the numbers were on that side.
Okay.
You're more than welcome to turn it around and say C is about 8.54. Makes no difference which side they're on, as long as the C is by itself. Okay? Good question. All right. Okay, let's look at some of the other applications and see what they got for you. There, I just got 2 triangles. What does it mean when they put these lines on the triangle like that? That the sides that have the same number of hash mark, the same number of lines, guys, shh. The lines that have the same number of marks are equal. So in this case, line AC is the same as line AB, right? Okay? And line AD is the same as DB. Okay? Notice it's 2 triangles. They're exactly the same. So and if the whole length is 20, what do you think?
10.
This one's 10 and that one's 10. If this line is equal to this line, so it's also 10. And so we just have to find the hypotenuse. Okay?
10 is 200 centimeters.
And the square root of that, whatever it is.
No, 20 times 27.
400, yeah. You're too big. Okay?
Things go on.
So it's 10 squared plus 10 squared equals C squared,
14.14.
which gives you, simplifying it, you end up with 200 because it's 100 each, equals C squared. Take the square root of both sides, and you get what, kids?
14.141356.
So 14.14 is about C.
Approximate.
Can you round it before you've done the perimeter of the whole thing?
No.
You probably shouldn't.
I've got a question.
Okay, I'll times it by 2.
Yeah. Just take your answer times 2 and then add in the rest of it.
So yeah,
The 20 centimeters. Yes.
just for say my answer that is equal to C squared is like 100. And so then when you square root that, it's a whole number.
Right.
Do not put the squiggle on.
Exactly. That's an equals, right? So like, for example, you got the square root of 49. That's just 7.
Okay.
So you do put equals for sure on those. It's only if you round the answer that you should put the approximately. And I don't know that they're going to make a big deal of it, but I do. All right. So hold on a second. So just 15 through 18, the odds. There we go.